Hello friends, this video on integrals part 3 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 and part 2. Understanding the indefinite integrals first now. Integration is nothing but the process of inverse differentiation. I'll tell you why. As I told in the mathematical curiosity, if I have the differentiation and I want to find number for which I got this differentiation, I could use integration. Same thing here. If for my number, so if you differentiate x to the power n plus 1 by n plus 1, if you differentiate this guy with respect to x, what you get is x to the power n. In the reverse way, if you integrate this guy, right, if you integrate this guy, you get the same value plus constant. This constant we explained why we get, because you differentiate this guy plus any constant, you get this guy. So this is how it is. Integration is nothing but inverse of differentiation. So you differentiate this guy x to the power n plus n by n plus 1, you get x to the power n. Similarly, when you integrate x to the power n dx, you get x to the power n plus 1 by n plus 1. Similarly, you differentiate sine x, you get cos x, correct? Then you integrate cos x, you get sine x. You differentiate minus cos x, you get sine x, correct? So you integrate sine x, you get minus cos x. Similarly, you differentiate tan x, you get sec square x. So if you integrate sec square x, you get tan x. You differentiate minus cot x, you get cos x square x. You integrate cos x square x, you get minus cot x plus c. So that is how you see differentiation is not, integration is nothing but reverse process of differentiation. There are more examples. You differentiate sec x, you get sec x tan x. Similarly, you integrate sec x tan x, you get sec x. You differentiate minus cos x, you get cosec cot, and you integrate cosec cot, you get minus cosec. You differentiate sine inverse x, you get 1 by root 1 minus x square. When you integrate 1 by root 1 minus x square, you get sine inverse x. Similarly, you differentiate minus cos inverse x, you get 1 by root 1 minus x square. You integrate 1 by root 1 minus x square, you get cos inverse x. Correct? Similarly, if you see for tan inverse x, d by dx is 1 by 1 plus x square, and other way around is also true. And cot inverse x minus cot inverse x is also 1 by 1 plus x square, and other way around also true. Please note here, in case of this, you integrate root 1 minus x square, you can write either sin x, sin inverse x, or minus cos inverse x. In this case, when you integrate 1 by 1 plus x square, you can write tan inverse x or minus cot inverse x. We'll have more examples for this integration as process of inverse differentiation. So you say sec inverse x, you get this guy 1 by x root x square minus 1. Similarly, other way around is also true. You integrate this guy, you get sec inverse x. Cosec inverse x minus cosec inverse x, you get the same value. You integrate this guy, you get minus cosec inverse x, and both are same actually different side. You differentiate e to the power x, you get e to the power x. You integrate e to the power x, you get e to the power x. You differentiate log x, you get 1 by x. You integrate 1 by x, you get log x. You differentiate a to the power x by log a, you get a to the power x. You integrate a to the power x dx, you get a to the power x by log a. So that is how the integration is as an inverse process of differentiation. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.